Rocks are an essential component of the Earth's crust, and understanding them is crucial for geology and earth science. Rocks can provide information about the geological history of an area, as well as insight into the natural resources that may be present. It is important to have a basic understanding of the different types of rocks in order to fully comprehend their significance. Igneous rocks are formed from the solidification of magma or lava. Magma is molten rock that is located beneath the Earth's surface, while lava is magma that has reached the surface through volcanic eruptions. Igneous rocks can be classified into two types based on their formation: intrusive and extrusive. Intrusive igneous rocks are formed when magma cools slowly beneath the Earth's surface, allowing large crystals to form. Examples of intrusive igneous rocks include granite and gabbro. Extrusive igneous rocks, on the other hand, are formed when lava cools quickly on the Earth's surface, resulting in smaller crystals or even glassy textures. Examples of extrusive igneous rocks include basalt and pumice. Igneous rocks also have unique characteristics that help to distinguish them from other types of rocks. For example, they are typically hard and durable, and often have interlocking mineral crystals that can be seen with the naked eye. Overall, igneous rocks play an important role in understanding the Earth's geology and history, and studying them can provide insights into past volcanic activity and the formation of the Earth's crust. Sedimentary rocks are formed from the accumulation and compression of sediment. This process occurs over millions of years and results in layers of sedimentary rock. There are three main types of sedimentary rocks: clastic, chemical, and organic. Clastic sedimentary rocks are made up of fragments of other rocks or minerals, and examples include sandstone and shale. Chemical sedimentary rocks are formed from minerals that are dissolved in water and then precipitate out, such as limestone and rock salt. Organic sedimentary rocks are made up of the remains of plants and animals, such as coal. Sedimentary rocks are important because they can tell us a lot about the history of the Earth. For example, the layers of sedimentary rock can give us clues about the environment at the time they were deposited. They can also contain fossils, which can tell us about the types of organisms that lived in the past. In addition to their scientific importance, sedimentary rocks also have practical uses. For example, many sedimentary rocks are used as building materials or as sources of fossil fuels like coal and oil. Overall, understanding sedimentary rocks is crucial for understanding the Earth's history and its current geology. In this section, we will talk about metamorphic rocks, which are formed when existing rocks are subjected to heat, pressure, and/or chemical changes. The word metamorphic comes from the Greek words meta, meaning change, and morphos, meaning form. Metamorphic rocks have distinct characteristics such as a foliated or non-foliated texture, which refers to the arrangement of minerals in the rock. Foliated metamorphic rocks have a layered or banded appearance, while non-foliated metamorphic rocks do not. Metamorphic rocks can be formed from different types of rocks, including igneous, sedimentary, and even other metamorphic rocks. The type of metamorphic rock that forms depends on the type of rock it originated from and the degree of heat, pressure, and chemical changes it was subjected to. Some examples of metamorphic rocks include marble, which is formed from limestone, and slate, which is formed from shale. Metamorphic rocks have various uses, including as building materials and decorative stones. Identifying metamorphic rocks can be challenging since they can have a wide range of appearances. Physical properties such as texture and color can provide clues, and chemical tests can also be used to identify them. Overall, understanding metamorphic rocks is important for geologists and earth scientists as they provide insight into the geological processes that have shaped the Earth's surface. In this section, we're going to talk about the rock cycle. The rock cycle is the process by which rocks are constantly being created, destroyed, and changed into different types of rocks. This cycle has been happening for millions of years and is an important part of the Earth's geology. The rock cycle consists of three main processes: sedimentation, metamorphism, and melting. Sedimentation is the process by which sediments are deposited and compacted into sedimentary rocks. Metamorphism is the process by which rocks are changed due to heat and pressure. This process results in the formation of metamorphic rocks. Melting is the process by which rocks are melted and then cooled to form igneous rocks. Each type of rock is related to the rock cycle in different ways. For example, igneous rocks are formed from the cooling and solidification of magma or lava. These rocks can then be weathered and eroded to form sediments, which can then be compacted and cemented to form sedimentary rocks. Sedimentary rocks can also be subjected to heat and pressure, resulting in the formation of metamorphic rocks. Understanding the rock cycle is important because it helps us understand the Earth's geology and how rocks are formed. By understanding how rocks are formed and how they change over time, we can better understand geological processes such as erosion, weathering, and plate tectonics. This knowledge is important for a variety of fields, including geology, engineering, and environmental science. Igneous rocks, due to their durability and strength, are often used as construction materials. For example, granite is used for building foundations and countertops, and basalt is used in road construction and as a decorative stone. Sedimentary rocks, especially those composed of organic matter such as coal, are often used as a source of energy, like for heating and electricity generation. Limestone, a chemical sedimentary rock, is used in cement production and as a building material. Metamorphic rocks, like igneous rocks, are also used in construction, such as marble and slate, which are used for flooring, countertops, and building facades. They're also used as decorative stones and in the production of sculptures. Understanding the different uses of rocks is important not only in construction but also in resource management and conservation. That concludes our discussion on the uses of rocks. In the world of geology, weathering and erosion play a crucial role in shaping the Earth's surface and the rocks that make it up. Weathering refers to the physical or chemical breakdown of rocks, while erosion refers to the movement of rock fragments or sediments from one place to another. Different types of rocks have varying degrees of resistance to weathering and erosion. For example, igneous rocks like granite are generally more resistant to weathering due to their hard and durable nature. On the other hand, sedimentary rocks like sandstone are typically more susceptible to weathering because they are often composed of loose grains that can be easily eroded. Weathering and erosion can take many forms, such as physical abrasion from wind or water, chemical breakdown from acids or other chemicals, or biological processes like the burrowing of animals. Water erosion, for example, can create canyons and gorges over time by carving away at rock surfaces. Freeze-thaw weathering can also cause rocks to break down as water seeps into cracks and expands as it freezes, eventually causing the rock to break apart. Understanding the effects of weathering and erosion on different types of rocks is important for geologists as they work to unravel the Earth's history and how it has changed over time. It is also important for those studying environmental science as it can provide insight into how natural processes can impact the landscape and the environment. In order to understand the different types of rocks and how they form, it's important to consider the concept of geological time. Rocks are formed over millions of years through geological processes such as weathering, erosion, and volcanic activity. The age of rocks can be determined through various methods, including radiometric dating, which measures the decay of radioactive isotopes in rocks. The geological timescale is a timeline that outlines the major events and geological periods in the Earth's history, based on the age of rocks and fossils. It's divided into eons, eras, periods, epochs, and ages, with each representing a different span of time and significant changes in the Earth's geology and life forms. For example, the Precambrian Eon, which began around 4.6 billion years ago and lasted until about 541 million years ago, is characterized by the formation of the Earth, the evolution of life forms, and the formation of the first continents. The Phanerozoic Eon, which began around 541 million years ago and continues to the present day, is divided into three eras: the Paleozoic, Mesozoic, and Cenozoic. Each era is characterized by distinct geological and biological events, such as the evolution of fish and amphibians during the Paleozoic era, the rise of the dinosaurs during the Mesozoic era, and the evolution of mammals and humans during the Cenozoic era. Understanding the geological timescale and the age of rocks is essential for understanding the history and evolution of the Earth, as well as predicting future geological events. It also has practical applications, such as in the discovery and extraction of natural resources, and in the construction of infrastructure and buildings that need to withstand geological forces. In this section, we'll be talking about identifying rocks. When it comes to identifying rocks, there are several methods that can be used. Physical properties such as color, texture, and hardness can provide clues to a rock's identity. Chemical composition is also important. For example, igneous rocks tend to have high silica content, while sedimentary rocks often contain calcium carbonate. Identifying rocks is important for understanding geological processes. By identifying the types of rocks in a particular area, scientists can gain insight into the history of the Earth's surface and the forces that have shaped it over time. Finally, rocks are also used in scientific studies such as dating techniques. For example, by measuring the decay of radioactive isotopes within a rock, scientists can determine the age of the rock and the events that have occurred in the region over time. And that's it for our video on types of rocks. We hope you've enjoyed learning about igneous, sedimentary, and metamorphic rocks, and how they are formed, their characteristics, and some examples of each type of rock. Thanks for watching.